Okay, so today's class we are going to discuss about. Today we need to start third unit. Okay, so this is PIC microcontrollers, PIC18 features, and PIC18 programming. It is a new topic to you, I think, right? So you still now you haven't studied about this PIC microcontrollers and all. Okay. This actually deals with we need to study about PIC microcontroller architectures, that is overview and features. What is hardware architecture, pipelining, and architecture of PIC18, pin description, memory organization, program memory, data memory, and register organization. And about the features, you have to study about IO port, timer, counter, CCP, PWM, and interrupt, serial communication, ADC, and then external memory interface. And when you start with the programming, we start with addressing mode, instruction sets, and simple programs. IO port programming, that is, we are going with embedded C programming only, not the assembly language programming. So timer counter, serial communication, ADC, and application case studies. Okay. So here, what is our aim is we are going to study an advanced microcontroller. Here you could understand that what is the difference between the basic microcontroller and the advanced microcontroller, and how we are going to develop a programming. So here we are going to use the same Proteus for simulation, and we are using CC8 compiler for developing your PIC18 programming. Okay, so we are going to install the software and we are going to do a programming. So I will complete the theory as soon as possible, and then we will start programming it. Okay. So once I'm started explaining you this basic features, and we will be doing the programming entirely. Okay. So first of all, we will start with the what is called as PIC microcontroller actually. So this PIC microcontroller is called as peripheral interface controller. Okay, so the definition for PIC is peripheral interface controller. So it means peripheral interfacing in the sense that is your IO interfacing, more number of IOs that can be interfaced with this PIC microcontroller. So it is also manufactured by Microchip Technology during 1989. It is a single chip microcontroller. So it is 8-bit microcontroller. It starts with PIC 10, 12, 14, 16, 17, and 18. So now in this particular module, we are going to discuss about PIC 18 series microcontrollers. It is an advanced microcontroller concept. So the CPU can access only 8-bit of data. So this is also an 8-bit microcontroller, what we have discussed in as 8051 microcontroller has. If more than 8-bit, the data has been broken into 8-bit pieces and processed by the CPU. 18 to 80 pin packages are available. So here it's not like 8051 microcontroller where it has a 40 pin IC and then it has a fixed number of IO ports. But here with the same PIC18 microcontroller family, we have so many features of microcontroller, like some microcontroller has 4 IO ports, some microcontroller under the series has 5 IO ports, some microcontrollers has 3 IO ports. Similarly, all the other features are having its own difference, but though it is coming under PIC18 microcontroller family. Okay, so the scaling the PIC microcontroller families, it starts with the functionality, and then it based on the performance. So it is the common development platform is called as MP Lab IDE platform. So until PIC18 microcontroller, it is 8-bit processor, PIC 10, 12, 16, and 18. And once you go with 24H, 24F, and PIC 13, 33, or the 16-bit microcontroller, PIC 32 is the 32-bit microcontroller. So why we are concentrating on 8-bit microcontroller? Parity, Anna class tab kuda. So why we are studying 8-bit microcontroller? Because you know why we are limiting to study in the theory practice, because the architecture itself will become a very big one, and then features, and then programming. Okay, so once you want to familiar more with this microcontroller, it is enough that we have to study only the 8-bit microcontrollers. Okay, so and beyond that 32-bit microcontroller, can you see the architecture becomes 2 pages, and then features also more, but the performance and application with embedded C programming are common. So that's why very simple microcontrollers start with PIC18 microcontroller we are studying in this particular subject. Okay, so here as you know, there are 2 architectures, main important architectures of and transferring data from memory to the CPU. First one is called as von Neumann architecture. So von Neumann have developed. Second one is Hardware University. They have developed this particular architecture. So here, this is very important. As a control engineer, you must know the once you study, you're familiar with microprocessor. You must know what is called as von Neumann architecture and what is called as hardware architecture. Okay, it is very simple. So there is a classification called as memory, in which there are two classifications. One is program memory and other one is data memory. So program memory, otherwise called as instruction memory. Program memory is otherwise called as instruction memory. So instruction memory means what? What does mean by instruction memory, Nadia?
Instead,
Yeah, where you're storing your instructions, right?
store,
So when you're starting writing your
storing.
instruction, yeah, move A comma B, you're writing instruction. For that equivalent opcode, for example, 08H. So at memory of 4100, you're writing all these instructions, right? So 4101, 4102, you're writing 020B like this. Okay, so these are all called as the instructions. That is nothing but set of operations that the microcontroller have to perform. So this is nothing but instruction. Whereas what is nothing but data? If you want to add two data like 08 plus 0AH, so this is nothing but data 2 and this is nothing but your data 1. So these two are the data. So in a common memory, if you're storing instruction as well as data, so that is nothing but it's simply called as the memory element, where it contains a program as well as data. Okay, so this is what as of now we have studied von Neumann architecture. It's a basic architecture where we have split the memory into program memory as well as data memory, where at a certain memory locations you're storing program, or at certain instructions you're storing a data. The common address as well as data bus is used from the microcontroller. So what will happen if you want to access the program or instruction, it will point out the address and it will fetch back. And then if you want to point out the data, the same address bus is used to point out the data, and then it will be fetched back to the microcontroller with the help of same address as well as data bus. Okay, so it is an 8-bit data bus and 16-bit address bus. As of now, we have studied. So this is what the architecture called as von Neumann architecture. So what is the disadvantages of this is because it takes more time, because you're having instructions in number of instructions, you have n number of data that need to be stored in a particular memory. So n number of data, let's for example you're taking a sensor, temperature sensor, you're reading data with respect to time, 1,000 data per second you're reading. Okay, so if you're using a common address and data bus, it is difficult for you to process the instruction as well as to store the data in the memory. So the advanced architecture was introduced called by the Harvard University, is called as hardware architecture, where and then complex instruction set architecture. So two types of architectures are being commonly followed. So after we find out the difference between these two, we could find what is the architecture was followed at 8051, what we are going to follow with a PIC18 microcontroller. It's simple one. It's a complex instruction. Regular and fixed instruction format is here. It is irregular instruction format. Simple addressing modes used here. Complex addressing modes used here. Pipeline, the instruction set is used. So I will explain you what is called as pipeline later. May also pipeline instruction is there in some of the microcontrollers, but most of the microcontrollers doesn't follow pipelining. So separate data and program memory. So once you have identified this instruction, now this belongs to PIC18 microcontroller, what we are going with. And this is what the architecture followed by 8051 microcontroller. Okay, complex instruction sets architecture. So combined data and program memory is here. Most operations are registered to register memory. Most operations are registered to memory. Data transfer takes place between register to a memory. Take short time to design and debug, and it will take long time. Provide larger number of CPU registers. It has smaller number of CPU registers. So it means, so it has less number of it has more number of instructions. One more important difference is it has more number of instruction sets. Instruction sets, it has less number of instruction sets. Though it has the RISC architecture is being followed with advanced microcontroller, it has more and more number of features, but it has less number of instructions. So how come these microcontrollers are using less number of instructions but which can able to perform more functions. How it is? Because it has a general format, like in C program coding. So we are following certain some standards, right? So here there is no specific instruction. Like for example, here we are using move a comma b, a specific instruction to copy the data from a to b. So there is a one more instruction. If you want to copy the data C to a, this is the second instruction that you have to use. This is the first instruction that you have to use. But here the instruction will be available at move rs comma, that is rs comma ri. It's a separate a common instruction format where you can use register a b or b c or cd or whatever it may be. Okay, so this is a common instruction format, but it is called as the specific instruction format. So once you go with specific instruction format, that's why you're having more number of instructions, that though it is complex, right? Can you understand what is the difference between RISC and CISC architectures?
Yes, ma'am. Yes.
Yes. So third important thing is pipelining in 8051 microcontroller. So now I just want to explain you. So you have a microcontroller. So you have a memory, right? So from microcontroller, you are transferring a data to the memory. I mean, you're sending the address where the data is located. So this microcontroller is acting as a courier office, where if you want to get a parcel from an individual house, so you're sending the courier man with the address. Okay, so this address is going, and then it will be pointing out a particular location, and then the data will be fetched back to the microcontroller. So now what will happen? In this case, so first what you have to do, first microcontroller have to give the instruction called as fetch. So fetch in the sense of what it has to send the address 4100 to the memory. So it has to point out the memory, and then with the same address the data need to be sent. So either it is going to perform that is the memory read function. You have memory read function, memory write function, IO read function, or IO write function. So these are all the functions that can able to perform. So all these functions are called as execute cycle, and this is called as fetch cycle. So fetch cycle is nothing but it is going to fetch the address in the memory, and then it has to send back to the microcontroller. So what the microcontroller has to perform after execution, that is it has to perform add function or something else, is called as the execute cycle. Okay, so now usually what will happen in 8051 microcontroller and all. So the first it has to fetch, sorry, you're simultaneously fetching n plus 1th instruction, and then after the cycle, so you're executing n plus 1 and then fetch n plus 2 instruction. So execution of previous instruction and fetching of next instructions are being performed simultaneously, called as pipelining. So this can be followed by PIC18 microcontroller, not by 8051 microcontroller. So these are all the advanced features are being used for advanced microcontroller concepts. So this is actually the simplified view of PIC18 microcontroller. So where it has, as like in 8051, we have CPU, central processing unit, oscillator for providing the clock sources, and we have timers, we have IO ports, and we have other peripheral features. We have RAM memory, and we have ROM memory, program counter, stack pointer, everything is the same. So you have two memory, that is nothing but so this is nothing but program read only memory, and this is nothing but data read only memory. So there are two memory, program ROM as well as data ROM. Then it will be processing it. So there is a logic called as interrupt control logic. So there is address and data buses available. So this is the simplified view of any of the microcontroller, not only for your PIC18. After the advanced microcontroller, which has different program memory and data memory, this is a simplified view. Okay, it's not actually deals with PIC18. Okay. So now the PIC18 microcontroller follows the hardware architecture. It follows the hardware architecture. So now you have microcontroller unit. So you have program memory, separate program memory, separate data memory. You have separate IO ports, and then separate supporting devices. So hardware architecture in the sense what, separate data memory as well as data memory is separate and the program memory is separate. So now program memory space for this. Okay, so now here, so you have to carefully look into it. So this is a PIC18 CPU. Now this is called as your data memory space. Data memory space, and now this is nothing but program memory space. So there is a separate program memory as well as data memory. So now can you look into it? It has 12-bit register address. So this is nothing but address bus length is 12 bits. It means what? 2 to the power of 12 is how much. This is what we have discussed, right? So these two are very very important. Like it is called as program memory and is called as the data memory, right? This is called as data memory. So data memory allocation space is not 4096 actually. The remaining bits are used for some reserved purpose. So out of 4096, 3968 bytes of SRAM is used. Okay, we will see the detailed architecture of this memory after that, and then it has sophisticated timer functions include that is it has CCP called as capture, compare, and PWM module. So that we will discuss later, and then separate PWM interrupt, and it has watchdog timer also. So I'll tell you later what is called as watchdog timer. It is. So it has serial communication interface, SPI, I2C, and CAN buses, and it has background debug mode options available while executing the instruction. Importantly, it has ADC. So what is the purpose of ADC? The analog signal can be processed with the help of this microcontroller internally. If it is 8051, you need to require AD0808, a separate analog to digital converter for performing ADC function. Okay, it has instruction pipelining. So maximum crystal frequency it is 40 megahertz. So memory production capacity is available with it. Okay, so this is the features of PIC18 microcontrollers. Okay, so how do you compare this PIC18 versus 8051 microcontroller? So while go with the architecture, PIC18 is RISC architecture, it is RISC architecture, and this program memory capacity is maximum 64. Here it is 2 MB. Data RAM is 4 KB. Here it is 256 bytes. So 4 timers. It has 3 timers. So 32 IO pins. So here it is 33. Vary based on pin packages. So both are having one serial port. It is inbuilt ADC, but there is no inbuilt ADC. So what main important difference between PIC18 as well as 80?
Ma'am, in 8051 there are two timers only, ma'am. Timer 0 and timer 1.
No, why it is 3 timers? Because this is 8051 family of microcontrollers. So in this 8051 microcontroller, also 8052 microcontroller has included. Um, so in 8051 you have 2 and 8052 you have 3. So here it has been
Okay.
given 256 bytes, right? But it is not actually 256 bytes. So in our system it is 128 bytes
128
of RAM.
bytes. Yes, ma'am.
Why it
Yes.
is 256? Because it is for 8052.
The 52.
Yes,
Okay.
this is also for 8052. So now this is the architecture. Okay, so tomorrow's class you draw this architecture in your notebook. So this is IO ports, port A, B, C, D, E. So this PIC18F458 microcontroller we are selecting. Okay, so the common architecture will be like this, but we are going to study only this particular microcontroller. So it is port A, port B, port C, port D, and port E. So IO ports, and it has AD converters. So here it is. You have erasable programmable read-only memory, parallel slave ports, addressable that is your serial communication port, master synchronous serial port, CCP modules, timers, and everything is available here. So here important loggers, ALU which performs arithmetic logical unit. You have working register. You have bitwise one shot pulse input which will be given. And then there is a register to perform multiplication. So we have this PRO D high registers and PRO D L register is for register selection operation. And sorry, it's not register selection actually. The product of multiplication function which will be stored in these registers. So register selection will be available here, file selection registers. Okay. So this is actually to perform arithmetic and logical unit. Here you have only one register called as working register. It's also an 8-bit register. Okay. And to fetch the instruction register is used, and instruction decoding and control used to perform to decode the instruction. So what instruction actually it is. So for crystal oscillator, timing pulse is given. So then it has power of timer, power on reset, watchdog timer, everything is available. We will discuss each and everything later. Okay. So here this block represents the data bus. Through the data you have data RAM, that is 4 KB of data RAM maximum. So the address for data RAM is 12 bits and data is 8 bits. So 12 bits is for to access 4 KB of memory. So this address, this memory can be selected with the help of file selection registers. Okay, so FSR0 and this is BSR register is also used here. And then so this is the RAM structure here. So you have ROM memory also. This is nothing but yes, this is nothing but data RAM memory, and this is nothing but program memory. So this program memory is up to 2 MB. So it has 21 bits of address bus and 16 bits of data bus. So this 16 bits of data bus can be decoded and it will be executed. So here it has, this is the program counter. Program counter is used to point out the next instruction to be executed in memory. Program counter is 21 bits. So 21 bits can be program counter high and program counter low. So program counter upper, high and low, individual 8 bits it has been divided. So 31 level stack is available. So this is not required actually. Table pointer, increment logic is internally available. Okay. So a simple block like this, it's the features, additional features. This is CPU block, and this is data RAM block, and this is nothing but program memory block. So here it is nothing but the program counter functions. Okay. So every the maximum memory 2 MB, which is internally available, no need to interface external memory here.